Hey guys, today we are going to implement a binary search tree. Okay, so what's a binary search tree? So I would like to repeat these 9 points so that you can have a basic grasp over this topic. So first point is a data structure in which the data is arranged like a tree, also inspired from the concept of binary search tree. So in a binary search tree, every cycle we just cut off half of our data, right? So it becomes uh, way much efficient and faster as compared to a normal search data structure, right? So the time complexity becomes order of log n, as I have mentioned in this 9 point, right? So in a tree, there is a root node at the top through which we can access our data structure. Each node can have at most two children. Okay, so one is left child and one is right child. Okay, the left child is always smaller than its parent, and the right child is always greater than its parent. Okay, so for example, if 12 is the root node or the parent node and we want to add 15, so 15 is going to be the right child of 12. Okay, and if we want to add 10, so 10 is going to be the left child of the tree or the parent, right? So traversing throughout the tree has three ways: in order, pre-order, or post-order. We will be covering the in order traversal. So what is in order traversal? It means the order goes like this: left child first, then parent, and then right child. Okay, so we will be implementing this data structure through recursive functions, and I hope that you all are aware of the recursion process in Python, right? So recursion, in short, uses stack memory, like a concept of last in first out. So last call goes first out. Okay, so let's start with our code. So, okay, first class is node class, similar to the linked list, right? And we have to define the init method, and init is going to take data and then parent this time, and parent is set to none for now. Okay, self dot data equals to data, self dot parent equals to uh, parent, self dot left equals to none. Initially there is no left child and there is no right child, so self dot right is also set to none. So we are done with our node class. Okay, now we have to make another class st, binary search tree. Define init. So self dot root equals to none, and just I'm mentioning this again, double underscore, oh, I should just write it, double underscore means strongly private uh, method or variable. Okay, so when we put double underscore in front of just before any variable or a method name, it becomes strongly private in Python. Okay. So now let's begin with our methods. The first method is going to be insert. It's going to insert some data. For now, I'm using the pass statement. Our next is going to be traverse. again pass. Okay. So first condition is if there is no root node. So when there is no root node, if not self dot root, then self dot root equals to node. Okay, so we have instantiated our node class when there is no root in our tree. Okay, and why we haven't passed the parent? Because the root has no parent. That's why we didn't pass the parent uh, attribute here, right? Okay, and if there exists a root node, so if there exists a root node, else self dot, I'm calling a different function here which I haven't defined yet. So insert data, and I am keeping this method as a private method, okay, so that the user cannot actually see the implementation. We study this topic under the concepts of oops. Okay, so it's going to take data and it's going to take self dot root. So it takes two things. First, it takes data, and second, it takes the node. Okay. Now we have to define this new method. Insert data. Okay. And it takes data as well as node. Right. Now, first we have to look for the data. Okay. So first we have to look for the data. And how are we going to look for the data? If data is smaller than nodes data, current nodes data. Okay, sorry. Okay, so if the data is smaller than the nodes data, and then we have to check if there is a left child to the node, then we have to again call this private method, and this time it's going to take data and node dot left. Now this time recursively this function is called again, and this time it is checking the data with the left in the left tree. Okay, so this time it's going to check for the data in the left tree, and again if it finds the data is still smaller than the nodes data, then again it's going to call it internally. Okay, and else node dot left equals to node data, and this time we are setting the node as a parent. We are passing this node variable as a parent. Okay, so obviously node is going to be the child of the previous parent. Okay, so node becomes the parent. Now similarly we have to cover the second half of this method. Elif data is greater than nodes data, we have to do the same thing. If there exists node dot write. Now, if data is greater than the nodes data, obviously we are going to check in the right tree. Okay, self dot, again calling the same function, and this time we are providing it with data, and node dot write. This time it's going to check for the data in the right tree. Okay, else node dot write is going to be the new node, and the new node takes data and the node as a parent. So again we are going to copy this line of comment, and we are gonna paste it in here. That node becomes the parent. Okay, now we are done with our insert method. Now we have to do the traverse part. Okay, so basically in a traverse method, what this traverse method is going to do for us is it's going to print out all the data in our data structure. Okay, in our tree. So again, if self dot root, it means if self dot root is not a none. So if it's not a none, it means a root exists. Okay, so if a root exists, we are gonna call a new method, and it's going to be called in order. I'm naming it as in order just to make it clear. Okay, and it is going to take node as its argument. Okay, now we have to define this private method called in order, and it is going to take node. Okay, so it is going to take self dot root, right? So it is going to, we are telling this in order method that start traversing from this root node. Okay, so now we have to first, so I'm just writing down the rule of in order traversing. So order is left child, then parent, then right child. Okay, so if node dot right left, all right, self dot in order, this time node dot left. Now we have to print nodes data, and according to the stack memory process, last call goes first out. Okay, so the last call will be the leftmost node's value, right? And then it is going to get cancelled, and then the previous of the last call is going to be executed, and then it is going to print the parent node, right? So this time we have to check node dot write self dot in order node dot write. That's it. That's all we have to do for traversing in order manner. Okay, now let's check our code. Okay, so if name equals main, tree equals to bst. Now tree dot see, we are getting these two methods, insert and traverse. All right, so we want to insert 12 tree, we want to insert this time 24 tree dot insert, we want to insert 10 tree dot insert, we want to insert 11 and again 0, insert 30, 3 dot insert minus 6, minus 3, insert minus 9. Alright, now let's check our traverse methods. So tree dot traverse, let's check it. Okay, so you all can see that our data structure is well arranged, starting from minus 9, minus 6, minus 3, 0, 10, 11, 12, 24, 30. So it is ordered in an ascending order form. So this code seems to work fine. So we will be covering more methods in the upcoming videos. Thank you.